Good morning, mathematicians. I guess we'll try talking about quaternions again today. But who knows? Who knows? We like getting distracted on this channel. So
Good morning,
we may just get more distracted. Hope everyone's gonna have a productive day. I felt like maybe I didn't. It took me a bit to get to sleep last night, but now that the coffee's hitting, I'm like, yeah, I am gonna get some work done today. Okay. Where did we get yesterday with all of this? Homographies. Okay, that's just some stuff about. Good morning, Kostaka Corey. This is just some stuff about projective, the derivative. This is what we need to know. Since the time of Hamilton, it has been realized that requiring the independence of the derivative from the path that a differential follows towards zero is too restrictive? Interesting. I look very tired? Oh, God. Do I? Okay, I'll take your word for it. I can't really tell. Let's. Ooh. Do I look tired? I don't know. I'll take your word for it. No. Good morning, Arad. Too restrictive. Okay, that's weird. Why though? Even it excludes even squaring. Huh. Really? I guess maybe that's believable. Because you end up having some. Like, I wonder, do you get some Cauchy-Riemann type equations? That would be my suspicion. Therefore, the direction-dependent derivative is necessary. A direction-dependent derivative is necessary for functions of a quaternionic variable. Interesting. You learned recently that Dirac operators are analogous to the Cauchy-Riemann operators. Whoa. That is cool. Huh. And that's apparently what leads to analysis on quaternions. Really? That makes it seem like analysis on quaternions is a more significant thing. I always thought it was just a curiosity, people developed it, but I didn't realize that there was actually any sort of application to physics or anything. Where this is a linear map, and O represents some continuous map such that this is true. Okay. But then they say you need a directional derivative, but then why did they call this the derivative? The notation doesn't seem to reflect a directional dependence. We'll need to go find an actual PDF in a second. Interesting. We still get some normal looking kind of rules. We're trying, Locke. We're trying. There's an old saying that the maximal equations were originally written down in quaternionic form. What? I've never heard this old saying. What am I looking at? Quaternionic analysis. Yeah, let's look at this thing. You knew a person who did this stuff. You got several SU2 and Quaternion videos. Okay, might have to go digging back through your catalog. For example, one about writing down the kinetic energy of a pendulum in SU2 form. That sounds cool. Okay. It's well known that discovering the Quaternions one had to wait another 90 years before this guy, Fwetter, produced a key result of quaternionic analysis, an exact quaternionic counterpart of the Cauchy formula. Because of the non-commutativity of quaternions, this formula comes in two versions, one for each analog of the complex holomorphic functions. Interesting. There's a determinant here? What are the Z and W? The determinant is taken in the standard matrix. Oh, in the matrix realization of that. I see. Okay. Intriguing. Pi became pi squared, so cursed? What? What are you talking about? Oh, in the denominators there. Yeah. SU2 actions for spherical coordinates, polymatrices versus SU2 basis. Those are your video titles? Unsubscribe here and move over, yeah. You can only you're only allowed to be subscribed to exactly one of us. It can't be neither and it can't be both. Choose wisely, friends. Choose wisely. Or don't. Maybe it works out more in my favor if you choose unwisely. I don't know. The Cauchy formula also provides extensions of functions on the unit circle to holomorphic functions on the disks. Also provides extensions of functions on the unit circle to disks and outside the unit circle. The dense subspace of trigonometric polynomials is identified under the isomorphism with the space of Laurent polynomials on the punctured complex numbers. Can you be subscribed to a superposition that it collapses? Ooh, interesting. I think we need to wait. In order to actually implement that, though, we'll need like a working quantum computer, Rod. I think that's the only way to truly do that. You posted the Quaternion Algebras book once already. Yes, you did. I do remember checking that out on your... Did that deal with analysis, though? That giant tome? Or that seemed like it was just algebraic theory. I mean, there's a philosophy lock that one should deal with subsets instead of points, right? So-called pointless topology. You learned some nice physicsy stuff from Hestein's book. Oh, it does zeta functions. Wow. Well, the reasons to seriously bite into that tome one day are stacking up, I'll be honest. By the way, you're making spaghetti with pesto and bacon? I mean, miss me with the bacon, but I'll have some peschetti. This is one of my favorite memes. There was a time I had it on my phone. There was a time I had it on my phone, and I would just look at it from time to time and just laugh to myself, just sitting alone laughing about this meme. Um, yeah, you gross biscotti. uh, I don't know why, but this one, and then this watermark here of sorts for watermarking Lord of the Rings memes. It's just incredible. But yeah, I don't know. This is, in my estimation, one of the best memes. If you disagree with me, you're wrong. Okay. Um, there's also a quaternionic counterpart of the Poisson formula for harmonic functions. Yeah. Crazy. This is in complete parallel with global conformal invariance of meromorphic functions under SL2. Oh, I missed something here. Space of harmonic left-right regular functions are invariant under the fractional linear actions of SL2 quaternions. This implies that the dense spaces of polynomial functions in the summands are invariant under the action of the Lie algebra. This heteroskedasticity. Speaking of that meme, heteroskedasticity reminds me of exactly of what Gandalf says in the meme. I mean, Pasquetti. Come on. You knew what I meant. Damn robots. Damn robots. I don't know why I just didn't click on the Lord of the Rings post. Right? I mean, he says skedaddle, skedoodle. To me, that's like very close to heteroskedasticity. You may as well just replace skedaddle, skedoodle with that. So, good morning, Raymond. There's a fantastic text, quaternion kinematics for the error state Kalman filter. I don't know. That sounds too applied for me. Too applied for me. I'm purebred. You know this. You know this from our half completed tournament. What is this even about? No abstract? Or does that come after the table of contents? There we go. An exhaustive revision of concepts and formulas related to quaternions and rotations in 3D space. Makes sense. Okay, rotation group and its Lie structure. Special attention. Ooh, derivatives and integrals. Provides numerous intuitions, geometrical interpretations. Intriguing. Yeah. Actually, I was just reading. There's this tweet from Jonathan Goddard, and he was talking about how he had an experience in his algebraic number theory course where he spent like 5 hours on a problem and had this terrible 3-page long solution, and then his friend in the course spent like 5 minutes on it and had this beautiful like 1 paragraph proof. Sup? Are you assuming that my sets are non-empty and bounded subsets of a larger set with the least upper bound property? You can't just assume that about people. God, the gall. Yes, other people have posted takes about it already, which are good. But anyways, I don't know. And he's like, uh, well, I'm too dumb. I guess I'll go be a pure mathematician. Kind of insulting to applied mathematicians. Um, but also, I'm like, yeah, maybe I should go be an applied mathematician. Uh, um, Clifford analysis slash geometric calculus is something you want to learn at some point. Well, it seems like you're already barking up that tree with your um, geometric algebra stuff. Do people usually force themselves to study? You love math, but studying every day for hours doesn't ever get easy. You push yourself for too long and now you're burnt out. Well, it's good that you booked a psychiatrist if you're burnt out. Now, do I have to push myself to do it sometimes? Yes. But to be honest, I don't like. I have a natural inclination to spend a lot of time talking about math. Like office hours. Yeah, I do feel some sort of obligation to hold them. Not that I do any actual studying here, but like I want to do them, and often it is not infrequently the case that when I'm forcing myself to work on what I need to, it's because I'm actually forcing myself to stop reading other math that is not directly relevant to what I'm supposed to be doing. So, I don't know. For me, it's just incredibly natural. I don't know. Yeah. Yeah, if it's harming you, then it's not important. Yeah, it's not important enough. That's true. Yeah. Uh, uh, Serene, I'm just messing around. I'm just messing around. I'm just messing around. One is that people should divorce themselves a bit from trying to be successful. I don't know. I don't see. I don't know if I disagree, but or sorry, I don't know if I agree, but I don't know if I disagree with that. Um, I think you need to find what works for you. Like the whole I don't know, hustle sigma grind set culture. There's a lot of people that are very into it. There's a lot of people that have the strong pushback. Um, yeah, I don't know. I don't know. I'm of two minds about it. Like there's a part of me that's like, yeah, let's go full cottage core and just sip cozy tea in the woods and live a slow, peaceful life and don't do anything. And then there's another part of me that's like, no, like take over the world, make $1 million and become God Emperor, There's two wolves inside of you, and they're actually best friends. But just learn the math, bro, is probably good, yeah. You mean a bit different if you're dirt poor? Yeah. But yes, that's true. Wolfram guy is definitely not dirt poor. Just do analysis on S3 and forget about non-unit quaternions. That's sacrilegious for this stream. That's sacrilegious for the stream. You're only like halfway there from GA experience. Supposedly a really good textbook for geometric calculus, but you cannot find a totally legally free PDF of it. He basically said this showed him not to pursue the super abstract stuff, which he put on a pedestal. Yeah, and I guess that is a good thing to not do. And yes, his stuff is still fairly abstract. Yeah, and I mean, one of the takes I saw was that like this guy was like, it's so funny that this guy who was studying at Cambridge was like, oh, I'm not smart enough, so I'll go do the stupid thing like studying, like making significant contributions to like physics at Princeton, and it's like, from one perspective, from his perspective, he's like, oh, I couldn't hack it. And then, but from like most other people's perspective, it's like, oh, this guy's like way more of a genius than I'll ever be. Which is fine. You know, I feel like a lot of people are in this position. You know, you could probably, you know, I could say I'm in that position to an extent, right? There's a part of me that's like, oh, maybe I won't hack it in academia, but then there's probably other people who are like, Jesus Christ, I'll never do, you know, PhD Langlands, blah blah blah. Actually, I don't think there's a. Is there anyone that feels that way? uh, um, did I participate in Olympiads growing up? No, never. Never, 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 never. I did do the Putnam a couple years, and I think maybe one year I got not 0 points, but most of the time I got zero. The God Emperor of Mankind was a mathematical and scientific genius, by the way, in 40K. Well, there you go. It's a prophecy about me, baby. Um, I did see one of the air dish problems was solved by AI. This time it seems more so for real. And then I also read a quote from Ravi Vakil about Gemini making a significant contribution to research. And now, by the way, so Nikolai, so we had discussed previous claimed solutions of of AI versus the Erdish problems, and you had accused me of being one of the people of moving the goalpost, and I disagreed with you because, well, that wasn't where my goalpost was set. But now, I would say that this has achieved the goalpost. I think that me and a lot of other people, um, and a lot of other people, um, um, have. So, yeah, we live in interesting times. We live in interesting times. Um, and you know, I've been in my personal life. I've been talking to ChatGPT a lot more. I can't say that it's really, you know, in the spirit of how helpful it's been for the Erdish problems or with Vakil's work. I can't say that it's helped me significantly on the project I'm working on at the moment to the same extent, but it's at least been helpful for me enough to type back and forth with it. So you'll admit it annoys you that people on X assign grand talent to the people they know are academics, like Asef and Hampkins are put on pedestals. I mean, hey, I'll put Hampkins on a pedestal. Man's incredible. He is, yeah. I think he's great. I think he's all around great. But they are just the online set theorists. Yeah, but I mean, Hampkins has had a long career, and I think he's put out a lot of interesting papers. I mean, for me, I knew about Hampkins long before I think I even had a Twitter account. Um, um, but yeah, okay, maybe you're right with people on X. Yeah, being out there, being extroverted seems to be half the meat. Yeah, you know, I have also sometimes thought maybe I should have a less honest persona online, and maybe I should just project one of more intelligence, and then I can just be a famous public intellectual, and then mid-witted people will like pay me to give talks on things I don't know anything about. You know, maybe being a grifter isn't that bad. So, guys, if this channel turns into a grift, you know, don't be surprised. We'll see how the postdoc applications go. If you know Ramanujan and Erdish backgrounds, they were the most nomadic mathematicians who were very poor but did not care. Um, Was Ramanujan that nomadic? I mean, he moved once to England. I wouldn't call him a nomad. Certainly not on the level of Erdish. And did Ramanujan not care about how poor he was? I think he probably maybe cared a little bit. Erdős certainly didn't. You like the vocal AI solver guy, the 21-year-old furry. Yeah, I don't know. Sometimes I don't love his takes, but Erdős was literally traveling and staying in friends' houses. Yeah. Unless the AI helps in solving a millennium problem, you're not taking it seriously. That seems like a pretty terrible. Why? Why? That seems dumb. What if it helps solve some protein folding that helps us solve cancer? What if it helps us solve the twin prime conjecture, the Goldbach conjecture? I mean that I don't know. That's just a terrible take. You think Hampkins wouldn't repost his MO answers? If he wouldn't repost his MO answers on social media, his upvotes would probably be more tamed. Maybe. But class, we're all about the off-topic questions here. Do I happen to know a method for generating random points in the Euclidean plane that is rotationally invariant, avoids symmetry, and can be computed quickly at any location? I don't know what you're asking, to be honest. Well, thanks for the comment on the beard, the real deal. You are the real deal. Do I happen to know a method for generating random points in the plane? Yeah, it depends what you mean by method. I mean, if you mean by method, you mean you actually want to like computationally yeah, exactly. And as Locke says, what does rotationally invariant mean? Because then if you picked any point, if you want it to be rotationally invariant, you would automatically have to pick an entire an Euclidean plane. You'd have to take an entire like n minus one dimensional sphere around the origin. Like equally dense. I mean, you mean with equal probability? Rotationally, like you could set something like this up theoretically. But I'm also confused. Like when you say, like, what was the term you used? A method for generating. Do you want to actually somehow physically implement this on the computer? Because then now we're now just talking about the Euclidean plane is normally real numbers, but you're not going to like store the real numbers on a computer, or just mean some way to like conceptually discuss this. Well, and then in that case, sure, you could just consider. Yeah, I mean, you could talk about you could like fix a radius and talk about choosing points with equal probability at a fixed radius from the origin. AlphaFold is overrated. It's not that helpful. Okay, but that's not what I wasn't saying that AlphaFold is the greatest thing ever. I was saying, what if AI helps us solve cancer? Like it just seems like a silly arbitrary thing to say. Oh, AI is only useful if it solves a Millennium Prize problem, or I'm not going to care until it solves a Millennium Prize problem. I mean, why wouldn't you take that same argument and apply it to literally every mathematician on the planet and say, oh, I don't care about that mathematician's work unless they solved the Millennium Prize problem? Like, that's silly, right? So, how to start non-commutative algebra or non-commutative geometry? I know this is gonna sound this may sound snarky or something, but you find a book on non-commutative algebra, non-commutative geometry, and you start reading. And if you don't understand, if you understand less than 50% of the words in chapter one, then, well, you got to go look up what those words mean, and maybe you're not ready for that subject. Yeah. I'm fortunate for specific recommendations. I don't know. Non-commutative algebra. I mean, just any sort of book on rings and modules. I don't know about non-commutative geometry. That's a whole other can of worms. That's more complicated. Definitely learn non-commutative algebra first, but any popular grad textbook on algebra would be good enough. You ate your pescetti, and you're gonna go skittle skadoodle. Goodbye, Nikolai. Hello, Fimnal. A non-commutative geometry. There's a big old cons book. Yeah. Can I name which areas of geometry which are non-Euclidean named? Their proper names? No, I'm not totally sure. I understand. What am I doing? Well, right now I'm just yapping about random stuff going on in chat, but we are trying to read a little bit about quaternionic analysis. In Minecraft, there are more blocks per second in specific directions. Not sure I understand. You propose the Dirac distribution concentrated at the origin. Yeah. Wait, the Dirac? Concentrated at the origin? I mean, I get, well, you're assigning probably 0 to everything else. Why don't I try twin primes problem? Might be easier than Clay Prize problems, so still impossible. I mean, why don't you try it? Because it's not a good career move. I like solving problems. And probably I'm not going to solve the twin prime problem. And literally none of my training has prepared me at all in any way, shape, or form to think about the twin prime problem. Okay. Actually, I should probably go soon. Yeah, I should probably go soon. Let's see. Let me just read a couple other things here. Conformal invariance. Unfortunately, the promising parallel between complex and quaternionic analysis essentially ends here. In spite of vigorous attempts, quaternionic analogs of the ring structure of holomorphic functions, local conformal invariance, Riemann mapping, and many other results never have been found. Such failure led Penrose to say quaternions do have some significant roles to play in a slightly indirect sense. Their influence has been enormous through various types of generalizations, but the original pure quaternions have still not lived up to what most undoubtedly have initially seemed to be extraordinary promise. Yeah. Interesting. Most interesting. Yeah, spherical, projective, hyperbolic. Yeah, I mean, I don't know. What is the easiest way to earn money as a mathematician? Not what I do. I don't know. Why is this paper have so much yap at the start? I mean, it's fair. It's a 60-page paper. It's a 60-page paper. It's a 60-page paper, so, you know, I think it warrants a lot of explanation. And I think it, you know, there's a mix of history, so there's interesting history here. I'm skipping it for now because I have no attention span. So I watch too many YouTube shorts. Yeah, quantum field theory. I wouldn't be surprised at all that there's quantum field theory wrapped up in here. Let's see. So, what do we have here? Quaternionic derivative. The correct notion of a regular function is obtained by mimicking this equation in complex variables. We define a formal analog. E1, E2, E3, those are quaternionic units, yeah. Because quaternions are non-commutative, this differential operator may be applied to the function on the left and the right. Yeah, interesting. Do I know any autodidacts who are very good at their specific areas? People who are self-taught? No, I just don't think that's really possible these days. I don't think that's really possible these days. Depends what you mean by self-taught, but EI is quite curse notation for quaternionic. I disagree, because probably, like, we're writing things out explicitly now, but probably it'll be nice to have compact formulas down the road. Nice. We've got a Laplacian. But why wouldn't... This is interesting. The 4D Laplacian doesn't seem... Oh, in this version... Yeah, why doesn't it have... I thought the square terms would have minus signs. Why is there a quantum field theory in a pure mass paper? That's a very normal thing. You need pure math for quantum field theory. These things... I mean, first off, these divisions between what is pure math and what is physics are artificial and ill-defined, and a lot of math and physics influence each other back and forth constantly. So this shouldn't be remotely surprising. Yeah. But I think that'll do it for today. Maybe I'll come back to this, but I'm thinking I want to spend some time reviewing stuff about algebraic groups. I sort of had this inclination. I was thinking about going through Springer's book on linear algebraic groups, but maybe it's better to do Milne. It's more of a where is the physics and chromatic homotopy theory? Just wait, Locke. But yeah, maybe Milne, because it's more of a modern functor of points approach. But there's something I like about Springer. I don't know. By autodidacts, you meant those who can't go to academia but can still afford to learn outside it? Yeah, but I don't think none of these people... I don't think there's any such people making serious contributions to the research literature, though. Unfortunately. There's maybe one or two people out there publishing, publishing in like hobby journals or something, but I don't know of any such instances. There's maybe more instances if you count. There's people who have gotten degrees in other fields and have gone on to publish in mathematics, but that doesn't really count because then they still went to academia and have usually found and have usually have some math adjacent formal training. You'd recommend Springer over Milne for what it's worth? Yeah, but the thing is Milne, I do like Springer. I'm feeling Springer in my heart, but Milne talks about the functor of points perspective, and is much more modern. And I think that's more useful for me for reading, for understanding a lot of stuff in modern literature. So I don't know. There are always exceptions. Well, Goddard, I would invite you to please send me people you think that have. Okay, here's the requirements: have publications in reputable math journals, and have never set foot inside a university, and are still alive, presently alive. I don't believe that there are any such people. Oh, you're not talking about adding the research. Well, then what do you? Then I don't know what you mean. Because what was your question? What was your original question? Do I know any autodidacts who are very good at their well, what would it mean to be very good at your specific area and not contribute research? And how would I know about these people if they're not contributing research? I mean, maybe they're making expository content, but I also don't know of any such instances. So, yeah, I don't know. Anyways, on that note, thank you all for joining me. Let's all go write some proofs and QED.